so let's start this. All right, we're gonna have to clean up some documentation in here. Do you want me to go over variance again, Lumi? You might already know what variance is, but I can go over it again real quick. And maybe actually, if I go over it, it might make for a better YouTube video than the pretty confident with variance. Okay, so where we got stuck last time, and I'll explain this part, is that T3 had T3, T4, and T5 we had trouble with. So turns out that T3 represents what's called an endomorphism, and an endomorphism is basically truly invariant, okay, in A. So A is invariant in T3A. We also, thanks to some help in Discord, not my Discord, but someone else's Discord. I don't know where it came from, so I don't know. I know who runs it, but thanks to their Discord, we learned that we're gonna put some notes down here about this. So let me bring up this other thing. So just give me 1 second. I want to set up some windows over here so I can read what you guys say and read this. Okay, so a covariant is a valid invariant. A contravariant is a valid invariant. Okay, an invariant which contains, I want to write this a little different, but we'll get there in a second. So an invariant, and let's actually capitalize these to discuss instances, I guess. So an invariant which contains hey Bredor, how's it going? Or Free Dan. I'll just use whatever's in parentheses because I can't read the Japanese characters. How's it going? I like that emote. It's cute. Neither a covariant, contravariant is a phantom. What did you end up using? Maybe I should do a very short video about how I set up my VS Code, and some of the pitfalls that come across with it. Okay, I think this is approximately correct. It might not be perfect. I abandoned my try. Oh, are you using Haskell IDE engine? Because that is a known issue. Let me explain both. So I want to change this a little bit. A covariant only has positive what's the term? Occurrences. If this gets, by the way, if this gets behind my face, just let me know, because I want to make sure everyone can read. So right, a positive occurrence is just this. So a covariant only has positive occurrences and is a valid invariant. Negative occurrences and is a valid I want to write this in a different way. So a phantom has neither positive, negative occurrences and is a valid invariant. An invariant is only invariant when it contains both positive, negative occurrences. Which Brett, or which packages are you talking about specifically? Yeah, I think we can fix, we know the answers to T3. Oh, so I don't use Cabal, but I think that your Cabal file would need to look something like this, where you have I guess, I don't know if it depends for you, right? But you need to include the invariant package, and then you need to build it, which does take a little while. Yeah, it takes quite a bit of time. Remember using different vocabulary with upper lower bound and assignable to instead of is. That's fair. I've not seen that terminology. I'm using the terminology that I read from someone else. So unfortunately, I don't have a great answer for that. Okay. For the functor, I think you mean the functor, right? Okay, let me make sure this is done. So an invariant is only invariant when it contains both positive. Yes. Okay, so important note. Give me 1 second. I will do that as the functor. Okay. Well, that's good. Something new is good. The folks that I was talking to are hardcore into category theory. So to be fair, I may be misinterpreting what they're writing. I think that I'm close, but I may be misinterpreting. So the invariant package implements invariant instances for data types which are functors covariant, which is why they use okay, the invariant package implements invariant instances for data types which are already functors. Our implement or T3 the function, I gotta go look up the name of that function real quick, but then we'll try the Bredor's case. Invariant Haskell And we want to look at the source code, and we want to look at InMapFunctor. Copy. Will not work for T3. Okay, so this is basically what I learned is approximately, hopefully this is written well, we'll read it out loud again. So the invariant package, which I was just looking at, you'll notice that it implements a bunch of instances of invariant, and almost all of them use this InMapFunctor function, okay? And the reason that you can do this is because these are already covariant. If they are covariant, you can simply use InMapFunctor, and if they're contravariant, you can simply use InMapContravariant, because these things already exist. The functionality already exists. Okay, but in our case, we neither have a functor or covariant or a contravariant. We have only invariant, which means these functions will not work for us. Okay, that's what I learned this week while messing with this. Okay, so these two are really easy, and then let's see if we can. I don't think this is a question anymore, so let's see if this works for here. T3 B F FAA B. Yeah, so this is a, oh, this is an A. Right, this is not a B. So what's the type of F again? A to B, and that's A to A. These are hard. I don't think that we want to try and implement, well, we can't, right? Because this is invariant only, it is impossible to implement this instance. So it's you can't, right? Like that's the math is, or the category theory, I think that's the way to say this. In category theory, you cannot implement that function because it is not a covariant. Okay, we don't need this anymore. That doesn't help us anyway. Okay, and then, yeah, I wrote this needs to discuss these thoroughly, but that's kind of what we're going to talk about now. Okay, so on Sunday, we got super stuck with that invmap function because we did not understand the relationships between covariant, invariant, and contravariant. So now that we understand those, these end up being a lot easier to write. Well, these two were just because I'm dumb, and this one was because I'm, well, I mean, it was all the same, I guess. The reason I went down that hole is because I wasn't thinking correctly. Anyway, okay, so for invariant, we have the following things. We have a function from A to B, we have a function from B to A, and we have a function from A to A. So basically, all you need to do is create a function of B, and then just kind of compose everything together. So you have a B to A, an A to A, and then an A to B. So this is all it is, and it's actually not very hard. When I initially wrote this, I forgot to put this FAA in. So you'll notice that if you remove FAA, it still compiles, but it's technically not correct because you need to have this A to A in there. And also note that this is a lambda that's unnecessary, so we can just remove it, and that gets us where we need to go. So this is the invariant instance for T3. And by the way, T3 is endo. the endo. I think it's a monoid. I'll call it the endomorphism, and we'll put a link to it. Google endo. Yeah, this is probably fine. Okay, so endo, it turns out, forms a monoid under composition. So that's, I mean, that's kind of neat. Oh, in the case of this, because you're, okay, so if you see anything like this, where you're composing functions and then applying them to something, and it's one thing, you know that this is unnecessary, because if you just compose these functions, they will require you to input a b. So if you look carefully, when we get rid of this, you'll see that, let me put it in, well, actually I should be able to just look at this. So, well, that's not super clear. Let me put this in parentheses. I think that should help. Right? So this is a function that takes a b and returns a b, and it's pretty, or I hope that it's pretty clear that when you remove the lambda, you're just applying this function to a b to get a b back. Does that help? I assume that HLint will tell us this. We can check. There's probably other things going on, but let's quickly HLint this and see if it tells us this or not. So HLint, I think you just give it the file. No hints. Okay, I lied. Sorry, wrong way. Still got to get used to this workflow. In this case, you need to compose these functions, right? IB is actually a function itself, and you need to compose them. So I think that you could remove it if you wrote the following, and we'll try it. Let me remove this before I forget. So in this case, you could write something like, actually, you know what? Let me do this. But I think we need a dot here. Yeah. So because there's nothing to apply, right? We need an actual function. I don't know if I'm wording this correctly. Hang on. We need to build a composition of functions that give us what we need, which is int a to int. And the only way you can do that is with this dot. You can't do that with the $sign. You put the $sign there, you'll get the wrong type. Well, no, I think the type is correct. What's wrong here, though? There's something wrong. I don't know how to explain this, Redor. Someone smarter than me can probably explain this. Well, what's the error? What does it say? What? Well, this is real weird. Couldn't match expected type. Yeah, that's probably true. I'm not terribly worried about this. Like, I actually think that this lambda is pretty readable in this case. In this case, you probably... Yeah. I think so. I think that's right. So for this one, I think you can make it point free. Is it still point free? I don't know if that's the right term here either. But I think we can do it with this one as well by going like this. I don't think we can. Oh, maybe. So we're gonna need a dot. Then we're gonna need... You need an... You need the F to go second. Oh. World Ender, you just said things that I don't understand. So, unfortunately not. I know a ProFunctor, an example of a ProFunctor, and I know that I want to learn lenses, but that's about the best I can do, unfortunately. I'm very new to Haskell, I would say. Can you make this point free? Because you need to apply F second. Really? Oh, yes. I know that this is called a ProFunctor. That's a fair point. I do know the definition of a ProFunctor, but we have not used them in any capacity whatsoever. I feel like this is close, but it's clearly not because that's a parse error. But maybe we need a... I think what we need is a... Is that a thing you can do? Oh my goodness. See, you're a better Haskeller than we are, so if you can't do getter ProFunctor lenses, I definitely can't. Yeah, this is cool though. So I feel like I've seen sections. I've not heard that term either. But this is exactly what we want. I don't think I've ever written anything like this. So you can write, just to satisfy my own curiosity, you can write things like this, right? +1? No, you can't. Okay. You have to write, well, no, you would write this. You would never write that if you wanted plus on the right side. So this is the same thing. This is exactly the same thing, right? Instead of saying +1 like this, you're just sticking the 1 here. It's kind of the same idea, right? Yeah, okay, cool. So yes, I do know that. So I could like completely remove this and it wouldn't matter. Okay. Yes, I've seen this before. But I've not seen section do this. Now, one problem with this workflow is I now need to put, if I want this attached to the other Google, I have to do it. Or I have to move it into the other space. I see. So we could do it like this if we wanted to. It would be ugly, but we could do it, I guess. Well, no. Maybe. Now I want to try. So I could do this, I think. No, it still's complaining. It's just a parse error, though. Interesting. I don't think that will work. For the same reason. Well, I don't know why this doesn't work, but I'm also not an expert. This is fine for me. Honestly, I think that personally, these lambdas are more readable, but anyway. Oh yeah, this is the above one. It's kind of funny. You got to do it this way here, because F goes first versus F goes second. So, Brett, or just for our knowledge, if you do it this way, like you just said, the F gets applied first. Yeah, this is exactly right. This. Yeah. Okay. This is useful. Very useful. By the way, I got a follower a day ago apparently, whose Twitch name is Benjamin Franklin's Gout. Just a hilarious name. I really enjoy that. I noticed it when I logged in today. Okay. For sake of clarity, I would prefer to look at this one to explain what's going on, because I think it's easier for my dome piece. Okay, so what are we trying to do here? I have this T4, and I know that T4 is contravariant, because A is in the positive position and the negative position at the same time. That's not the way to say this. It's in both the positive and negative position, so you multiply them together, you find out it's negative, and therefore it's contravariant. So what we're trying to do is write a contravariant instance for this, such that we can map a function a to b in reverse over this function here. So to do that, you start with an int b int. That's why it's I should probably call it IB, because we're doing contravariant. Otherwise it looks more like covariant, and fibby is more fun to say, I suppose. So fibby is an int to b to int. F is an a to b, so we need to map that backwards, is that the right term? Over fibby. So you'll have this function, which is an int to an a, and then you need to compose that with your f to get a b, and then apply that composition with this function. How do we say that? I think this is termed and then. Yeah, map backwards. Yes. Contramap. That's a better way to say it. Map backwards. All right, so let's discuss this composition just a little bit. This is all that's left on variance, and then we're going to talk about type scoping, type applications, and ambiguous types. And the only thing that I felt like I was a little confused, not confused, but rough on, was the ambiguous types part. So we'll probably talk about that a little bit longer than the other things, but I think the type scoping is obvious for anyone who's ever looked at Haskell before. And the type applications is more or less just going to be a demo. I would like to write this. I would like to write the tests at some point for this. I don't know that I started them. Did I start them? I haven't even started the test yet, but I would like to test all of these at some point. But we can say that for another time if you want to talk a little bit more about other concepts instead. I'm fine with that. Okay, so this takes our function a to b, which is f, right? Our function from int to a and gets you the int to b. That's what we need. And then once we have our int to b, we can just get our function into b to int. And that's all you need to do. This one's not very complicated. But we'll get rid of this and put that back. This one's actually even easier because it's more sort of the way you would normally see things. I think fmap makes a little more sense to me anyway, than contramap right now, but that's just because I'm more familiar with it. So this time you have a b to int, right? And your f is a to b. So you get your a to b and then your b to an int, and then you just apply that here. So wait, that seems wrong. This takes an a to int. Right. We need a function from a to int to int. Right. Okay, never mind. That's easy. Apparently it's not that easy because I got confused immediately when I looked at it, but it's not that bad. And then these are the fancy point-free versions of those functions, which are pretty cool looking, actually. And we remembered this, I guess. We sort of knew this exists, but we remembered it, which is nice. Okay, and then the other piece of information for variance is there are things called Byctors, which actually we've talked about before and implemented. But either and the tuple operator are covariant in both of their arguments a and b, and those are called Byctors. And the arrow function, which we've done a lot with, arrow operator. I think people call this the small arrow operator, because I think I've seen a name for the double arrow, which I don't use in this, but I've seen now large arrow and small arrow operators. So anyway, the small arrow operator or function operator is contravariant in its first argument and covariant in its second, and this is known as a ProFunctor, which we were talking about before. So I don't know a ton about Byctors or ProFunctors, but we have implemented a Byctor instance before. But you know, there's probably a lot more going on with Byctors than what we've done thus far. Okay, so I think that's it for this code, and the only thing we're missing here is tests. So I'm gonna put in the README a to-do section. It sounds like Breador is itching for more stuff, so we can do other stuff. That's fine. Add property tests. Okay. I think that's all we need for that. And then now, why is there two things? Oh, right. Of course, there's two things. So, no. So before I was just as knowledge, for chapter 1 and 2, I had the directory and then a subfolder, but I realized that this subfolder is going to be the same every single time, whereas it was a little different in thinking, not with Haskell programming from first principles. So I'm just going to call each chapter its own stack project and be done with it. Okay, so first things first, we're going to pop this open, and this is called working with types. And we want to go into here, clean this junk out, and clean this out. We're probably not going to put anything in main here, so we'll just do this. Okay, so we should, maybe everybody knows this, but Hindley-Milner. So yields the ability to infer types programs without specifying them. So technically, in our Haskell code, because it's Hindley-Milner, we don't have to put any types in there. The types are just for us, and it just makes our lives a little easier. Okay, and then the point of this is that you can create. Yeah, I don't want to do that. That sounds very hard. It seems like a really cool thing that can happen. Like how that actually works internally is probably pretty insane. Have you done it, World Ender? Actually, I guess your name. I suppose it could be World's Ender or World Sender. I think I want to call you World Sender because it's funnier. Ooh, interesting. Unless you hate it and you'll leave forever if that's the case. Oh my goodness. This sounds amazing. I have not seen this before. Thank you so much for this. I will bookmark it immediately. This is something that I would love to do on stream. I would absolutely be elated to do something like this because I'd probably smash my head against the wall for the entirety of it, but it would be awesome to watch me do it. By that I mean smash my head against the wall. You can just laugh at me. B. Okay. I just assume people would laugh at me. I mean, I would laugh at me. Okay. So here's a apparently very classic case of, you writing something that you think is correct but is not correct. And it's very clear in my editor for obvious reasons, but you'll note it says couldn't match expected type B1 and actual type B because this B and this B are not the same B. Oh, sorry, I didn't notice that. Let me look at that again. I didn't read it very carefully. Oh wait, who's in chapter 4? I'm confused. Oh, you mean, I see what you mean. Is it Steven or Stefan? Mr. Deal is in chapter 4. Chapter 11. 4 years into. Okay. I see what you're saying. Sorry, it wasn't obvious to me. And I like that it's ambiguous, but I'm going to call you World Sender because I think it's funnier than World's Ender for whatever reason. Okay. Back to this. So these bees are not the same bees, and there's a name for this, and I was trying to think of it when I was reading this chapter, and I can't remember what it's called. The something, is it alpha or beta or gamma equivalence or something? Something equivalence, I feel like. Alpha equivalence. I think it's alpha equivalence. Okay, that doesn't want to load. Alpha. If somebody knows the answer to this, then you can tell me. Yes, yeah. So basically, these two things here. Oh wait, this might be behind my head. Hopefully not. But lambda xx, lambda yy are alpha equivalent. You can insert any value in there, and they're the same. Maybe that's a bad way to say this, because this can be any value and this can be any value, but these two types are not the same. That's the point. Well, I guess it can be anything but A. There might be better terms for this, but I'm not an expert. I don't claim to be either, so I think it's okay. Anyway, the point is that this can be C, and it's... Oh, that's interesting. This could be C, D, E, doesn't matter. They're different, so this doesn't work. Yeah, we're going to talk about that here in a second. So, you can make this work by using something called scoped type variables. So we're going to start enabling some type level stuff. Language, or some, not type level stuff, some, oh my gosh, what are these called? Extensions, my goodness. So scoped type variables. Okay, so we need scoped type variables, but with scoped type variables, you need that explicit for all, like you're talking about. So you need for all a b dot, and then that, and this needs to go back to b. Okay, so this is saying with this on, by the way, if you turn this off, this will still fail. I assume. We may need to restart GHC. This seems not to complain, but I'm also not getting any type checking, so something appears wrong. I'm gonna reload VS Code because it can be... Let me make sure I don't need to do anything. Rizeri, thanks for the follow. I really appreciate it. Hope you can learn something, and that this is interesting. I appreciate the follow. Actually, this... You can't hear anything. You always have problems like that, I feel like. Everyone else seems to be okay. Or am I dropping frames all of a sudden? I did drop a few frames, but not many. Also, everyone needs to wish Newmade a happy birthday. It's his birthday today. Well, yeah, it's their birthday. Okay, so this fails, which is okay. There it goes. Now it's working. Yeah, so now it says you need some language extension to make this work. So I didn't realize that for all syntax was from the scope type variables extension. That's kind of interesting. Rizeri, question for you. If you feel like chatting, you don't have to chat. What's your experience level with Haskell? Have you done it before? Is it just something that you're kind of interested in it? Oh, I see. So I can only use for all A. If I'm reading that correctly. Monomorphism restriction. That means like single A, right? I don't know. I don't actually know what that means, so I'm just making sure. Okay. Yeah, I think that was the one that it suggested, right? Ugh, I don't want to do that. Explicit for all. Without the scoping. Okay, interesting. So it's like a less powerful version of this. Or for cases where you don't want that, I guess. For whatever reason. Okay, so yeah, this is fixed by doing this. So what I should do is make it broken and change the name. Fixed. And we will remove this. Comment this out. And then just put a note up here. This is broken because apply B is not the same B. Okay. This works because scoped type variables. What's the right terminology here? Fixes? Binds? Okay, introduces a type scope for A and B. And exposes them to the rest of the function. Okay, I think that's useful. All right. So the next thing is maybe a little weirder. Okay, it says scope type variables lets us talk about types, but we are still left without a good way of instantiating types. If we wanted to specialize fmap to maybe, for example, the only solution sanctioned by the Haskell report is to add an inline type signature. By the way, what's the Haskell report? I didn't actually Google that. Are we okay looking this up? Because I've never heard this before. I probably should have, but I haven't. Oh, it's just the standard. Okay. So this is the Haskell 2010 standard. Wonderful. I've just not heard of it before, which is hopefully reasonable. I'm not actually sure. So I noticed a few people hopped in just a minute ago. So what we're working on right now is thinking about types specifically in Haskell and how this scoped type variables language extension helps us explicitly use types A and B in our functions. So this works, but this does not. And now we're going to talk about how you get access to a type's name using proxy, which I've never used before. So it said if we wanted to implement a function that provides a string corresponding to a type's name, it's unclear how we could do such a thing. There's no way to explicitly pass type information, and so calling such a function would be difficult. There was a way to do this, I guess, with proxy, but apparently there's a new way to do it with type applications, I think. Okay, so let's get that in here. Whoops. Type applications. Ugh, can't type today. All right, so type applications allows us to do interesting things. So we might actually do this in the REPL instead of in here because we want to see the results. So that's what we'll do. So you can look at things like this. So, well, first I need to turn it on. type applications. And then if we look at the type of fmap, for example, you'll see the normal fmap that you would expect, nothing strange here. Some function a to b, some functor of a, some functor of b. But you can start specializing the types here. So, and this comes from this type applications thing, language extension, sorry, not thing. So you can say like fmap maybe, and then what it'll start doing is binding to, let me make sure I use the right term here. It starts binding from basically the left to the right. So it starts on the left of the fat arrow to the constraint functor of f, and then, you know, starts applying these types. So you could say things like I guess you could say like int, and then that would specify completely the, oh, that's interesting. I wasn't expecting this. I was expecting this to say fmap maybe. So this is interesting. Maybe there's a mention of this somewhere. We'll keep reading, but there's probably a name explicitly for this, but this is some kind of what is this? I don't know what this is called right now. Anyway, you can see what it's doing. It's specializing our function to specifically int to int, maybe int, maybe int. Yeah, I think this type applications looks kind of cool, just for the specialization piece. But we're gonna play around with its pitfalls right now, and then hopefully we'll see an example of why you'd want to use it. I think we'll look at like the example that it showed before. So my understanding, let me read this real quick. 2 rules to keep in mind. First is that types are applied in the same order they appear in a type signature, including its context and for all quantifiers. This means that applying a type int to a to b to a, let me create a function. So I don't want to read this, I'd rather show you. So if we had a function, which is an a to b to a, right, and we have to undefine f, and we do type f at int, you'll see that it starts applying at a. So it will replace the a's because they come first. It doesn't matter if that was a c, right? That doesn't matter at all. I could write c, b, a, and that would still put the int in this place. But we can also do, you know, this, and it will say int, integer, int. But I couldn't do another one. I assume it will fail with some error. Yeah. So cannot apply expression to a visible type argument string. That's kind of a weird error, I suppose, but you know, there is no type to bind this to, so it complains. And remember, it does include the context, which I guess is the left of, sorry, the context is the left of the double dots. Has anyone heard that term before? Context? I want to make sure that's the right term. Context and for all quantifiers. Okay. And also you can skip over pieces. I think so. Let's try it. So G is G. I'm not 100% sure this is going to work. No, because that's not a... You would have to write... Well, I don't know how you do that. There might be a way to do this, but we don't know how to do it yet. And it doesn't sound like Lumi would know this offhand either. So maybe nobody wished Newmate a happy birthday. Rude. Just kidding. Maybe World Sender knows. Okay, the only other thing that I want to show right now, we'll keep this in mind because maybe there's some way to do that. I just don't know what it is. If G Oh, maybe parens. We can try that. I'll try anything. I mean, no, that still fails. Let's try Lumi's other, or not Lumi, Brader's other suggestion. F at int. Yeah, look at that. That's neat. So you can specify. All right, I'll try that too. I don't think that's gonna work though. I think we would need to write, at least put a T in front of it, right? But this seems to work. Can you guys read this okay? Sorry, I always feel like you're not gonna be able to read this tiny font. This works though, which is neat. There's no implementation, right? Because it's undefined, but you can write a G that's specialized for your case, I guess. So that's neat. I didn't know that. And we can also skip over things. So this is the other point, is you can write something like f at underscore at integer, and it will leave the outer type, in this case, polymorphic. Usually the term specialization implies some kind of runtime specialization. Runtime specialization. That could, yes, that could be, because that's what we're trying to do, right? We're trying to do runtime specialization with the types, I guess. Although I suppose you could do it at compile time, I'm not sure. But I think the whole point of this is runtime specialization. Maybe not the whole point, but what we're getting at is that. Now the only thing I don't understand is they're talking about proxy bool, but we don't. It doesn't show an example of you using it. Maybe, oh, maybe that's coming up. Yes, it is. Okay, so let's go in here, and we're gonna write this code in here. Type name for all a typeable string. Type name. This probably won't compile. I probably need to import something. Well, it says right here, so I'll just import it real quick. Import data.typeable. Oops. Show type rep proxy a. What's this complaining about? Scope type variables. I got these two things. Oh, I'm going, why is this failing? The whole point of this is that A is ambiguous. So you need to deal with A. That's the whole point. Sorry. I was like, why is this failing? Okay, aren't reserved for functions. Sorry, I need to read this a little carefully, and then I promise we'll start talking about it. Okay, so here, this A right here, it's flashing, does not appear on the right side of the fat context arrow. So I guess this is the context here, not to the left of this. This is the context. Because Hindley-Milner's type inference only works to the right of the context arrow, it means the type parameter A in type name can never be correctly inferred. Okay, so this A is not subject to the scope binding from scope type variables. So this A is actually a polymorphic A. Okay? Are we okay with that? So because that A is on the left of fat context arrow, it is ambiguous. Maybe polymorphic is not the right term. Ambiguous is probably better. Okay, so to deal with this, you need another... Oh my goodness. Allow ambiguous types. Okay, so if we add allow ambiguous types, then we can do this. And then apparently we can just use it. So let me show you how you use it, which is actually pretty cool looking. So we reload, and then we can just do X type applications. Oh, you need to explicitly write set if I remember correctly. You can't write -s, that's not a shortcut. But you can write like type name at bool, and it will print bool. At string. Ambient. That's pretty cool. So this comes from here. This is neat, right? So apparently this was a little more frustrating back in the day. I don't know how long ago that was, but this is pretty neat. This is very cool. That's not what I wanted to do, sorry. What's next? It's as though this is a silly example. Ambiguous types are very useful when doing type level programming. Often we'll want to get our hands on a term level representation of types. I think this is what you were telling me about before. What is, oh, the type name is this function. So it's show.typerep applied to proxy at A. So proxy contains, if I remember correctly, let's go look this up real quick, because I think proxy is just a phantom type argument. Oh, I see what you're saying. Sorry. I'm gonna guess that it fails. It just uses it. There must be like a typable type. Yeah. That doesn't work because it's not specialized. So you need to proxy A into something to make this work, I guess. But like you said, A is ambiguous again. It just doesn't use So I can already feel like this workflow doesn't quite work the way you want it to, because if you go down, then the Google Chrome ends up with your control tab. So you still have to control tab twice anyway. So it's not really saving you any clicking, typing. Anyway, that's pretty neat. Okay. All right. Unfortunately, I really need to use the bathroom. So I started drinking a beer, and apparently that was a mistake. Give me 2 minutes. And oh, actually, let's do this. I'll give you some homework. I don't know the answer either, so we're gonna learn together. Ugh, can't type. Okay, so oh, okay. Let me add that first. Okay, so are all of the type signatures non-ambiguous? Always unit A to A, B to always unit A to B, show A always unit A to string. And I will be right back in just 2 minutes. Okay. Sorry, that was a little longer than 2 minutes, but I did my best. Yeah, we have a Discord. So there's just a invite link underneath the stream right now. You should be able to get it. Yeah, so that's always something. The i3 window manager. That's always something that I've thought about doing, but I've gotten lazier in my older age, I guess. Like I used to install, Arch Linux and build the exact machine that I wanted, but now I've gotten lazy, and it's not a good thing, but that's what's happening. Okay, so I know the answer because I've already read this, but seeing this fat arrow should, I guess, send you a sign something's going to be problematic, because we're not going to be able to infer what A is. So yeah, so the problem is that it's not clear which show A instance we're asking for. Even though there's an A, we're unable to access it. Always unit A is equal to unit for us, right? So that's it. And it says, consider an analogous example from cryptography. Oh my goodness, I can't read. Cryptography. Just because you know the hash of someone's password is something doesn't mean you know what the password is. Any good hashing function, like always unit, is one way, right? One way. You can't get an A back from unit. Just because we can go forward doesn't mean we can always come back again. The solution to this is called non-injectivity. The solution to non-injectivity is to give GHC some other way of determining the otherwise ambiguous type. This can be done, like in our examples, by adding a proxy parameter whose only purpose is to drive inference. Or it can be accomplished by enabling allow ambiguous types at the different definition site and using X type applications at the call site to fill in the ambiguous parameters manually. So I think what that means is if we had a function, so let me just convert these to functions. So f G, and we'll see which ones fail. H. Well, they all seem to work because I'm using allow ambiguous types. But I guess if I turn allow ambiguous types off, this should fail. Let's ensure that that's the case. Yes, wonderful. So this fails because A is ambiguous. Unless I use this language extension. Okay? So this is ambiguous types. And that was literally the entirety of let me put this one. This one is ambiguous because we don't know which A to use for show A. Unless we use allow ambiguous types. Also, Bredor, I'm thinking about this. If you don't really want to get on Discord, you can just DM me. I won't read my DMs during this because I don't use the Twitch interface. Okay. So actually that's chapter 4. So we're actually done with that. All right, so in here, we are going to discuss constraints and GADTs. So I think last time I mentioned that I don't know how to pronounce this acronym as people read it, but the book tells me that it is GADTs. GADTs. For reference, if there are folks who did not know that before, because I didn't until I read this. Okay, so again, so at some point I need to make a it's a lot less struggle, that's for sure. I was forced to do some work in the other case, right? Suppose I should write like hello chapter 4, but or 5, but it's probably not that important. Okay. Chapter 4 is definitely easier. By the way, thanks to Benjamin Franklin's Gout and Rizeri, we are, I think, 5 followers away from affiliate, which is pretty cool. I think we're at 45 followers. We're very close to affiliate, which is neat. 6. Oh, I was 1 off. Unfortunate. But we're close, so that's cool. I'm pretty excited about that. I feel like I'm making progress with streaming, and there's some pretty fantastic folks hanging out. So, thank you. Appreciate it. Okay, so we're going to talk about constraints. So, constraints are odd. They don't behave like types, nor like promoted data kinds. They're a fundamentally different thing altogether, and thus worth studying. The constraint kind is reserved for things that can appear on the left side of the fat arrow context. So examples of constraints, if you're unfamiliar. Yeah, Benjamin Franklin's Gout. By the way, fantastic name, and I appreciate that you followed me a day ago. Thank you. We're discussing constraints in GADTs. I gotta get used to that because I want to call them GADTs, but apparently that's not how you pronounce it. So, but I appreciate you following. Okay, so let me show you an example of constraint just so we know what we're talking about. This is a lot of A's, but sure, this. This is just a re-implementation of show, I think. Oh, well, right. Not put Sterling, show. Okay. This on the left, this whole thing is a constraint. So, and constraints can only show up to the left of this fat arrow context. Oh, nice. So, do folks just call that the Haskell chat Discord? Or is that Emily? Is that how you would say that? I was trying to think of on Twitter, it's, hang on. Yeah, Emily Pie. I don't know if it's like considered personal or just generic Haskell chat. I found it on Twitter and joined randomly, but it's been very useful. We had some nice conversations in the beginners chat about the chapter 3 of this book, actually. So it was pretty fun, very useful. Okay. So this is a fully saturated type class that ends up being a constraint. There are other constraints, tuples of constraints, which we've also seen before. And then also there's type equalities. And we're going to discuss what type equalities are here in a second. So hopefully we'll see an example. That's the first time I came across these. So I don't know if anyone's seen them before. So type class constraints are certainly the most familiar, right? This is quite familiar, and tuples of these things are pretty familiar. We use them all the time, even when we're not writing type level Haskell. So here's another example. If you write, I don't know, b equals 1 equal 1, right? You're actually using a constraint without even knowing, because 1, or num a, which is actually an integer in this case, has an eq instance, right? And because it has an eq instance, you can write this. Otherwise, you would not be able to. So you are actually using a constraint whether you know it or not, or it becomes obvious. Type equalities are more interesting, and you can use them by enabling a language extension. Who in chat has used GADTs before and knew that Well, we'll start with that. GAD. I see. There's a functional programming Discord as well, though. I suppose I should probably check that one out too. Actually, we should check that out, I suppose. All right, so Bredos used them. Who knew that they were pronounced GADTs? That's the next question, I suppose. Because it seems wrong. I will believe Sandy that it is correct, but it seems wrong. Okay, so this GADTs extension allows you to write some, I guess, some interesting things. So let's start with that. So 5 equals 5. And then you can also write the following. 5. I'm going to write prime because I like prime better than underscore personally. But Sandy uses underscore, which I suppose you could also do. Writes the following. 5 prime equals 5. So these two things are identical as far as Haskell is concerned. But this is a specialized, this is just an example where you are constraining a data type. Apparently you would, no human would ever write this, but you can. So type equalities form an equivalence relation, meaning that they have the following properties. Okay, so whatever, A, B is called a type equality. Type equalities form an equivalence. That's a weird way to say that. Well, that's what it's written as. Equivalence relation. Meaning they have the following properties. 1. Reflexivity. A type is always equal to itself. In other words, A. Symmetry. A to B holds if B A. I probably shouldn't plagiarize. To the best of my ability. So I've considered Idris, but I have not done. I know of Agda, but I thought that the next thing I wanted to play with, which by the way is probably a million years down the line, and let me show you why. I will show you why just real quick. So if you want me to learn something, you can put it here. But essentially I have 1, 2, well, we're working on this book now, right? 1, 2, 3, 4, 5 books on deck. There's this book, which is not done yet, but in theory could come out. Haskell in Depth, also not done yet. There's 2 courses from Data 61, as well as this lens tutorial. I've seen a ton of discussions about deriving via. We've had conversations about NICs, free and freer monads, tagless final, just generally, like I'm not a CS person, so I'd like to learn about algorithms, web APIs, databases. Like this is probably years, maybe a year of stuff left. So there's just a lot to do in Haskell, right? So I don't know that we're going to get to Agda or Idris or something anytime soon, but I will say that I'm genuinely interested in those things. So, you know, maybe we could take a day and like play with other languages or something. I've considered that as well. Or like I have friends also that are learning programming, so it might be funny to like troll my friends while, you know, they're streaming, but you know, we're in the chat like making fun of them or something. Not making fun of them, but you know what I mean. Goofing with them. Anyway, transitivity, if both A, B, and B, C, then we can infer A, C. Yeah, that could be an interesting way to do it. Like just try and add in little bits of other things in there, because yes, we might get to a point where I mean, the other thing that Lumi was talking about before also is maybe we should start a project as a stream, so like a Haskell project. So we're gonna be super busy. I don't see ourselves having a lot of time in our lives, like unless I start streaming more, which I might. But I don't know when that will happen. We'll have to see what happens in the next few months, right? I really don't know. But I am open to it. That's the whole point. Okay. So that's all we got for type equalities, and now we'll talk about GADTs. So this is an extension to the type system, and we can basically write explicit type signatures for data constructors. So the canonical example of a GADT is a type-safe syntax tree, for example. So let's declare this. Expert A, where, excuse me, lidint I think this lit, by the way, is supposed to stand for lift, but I'm not 100% sure. It seems like lift is what we're looking for here. So once I finish this, we'll have, oh, literal int. That makes sense. That makes sense. That makes more sense, for sure. Because you're not really lifting. Well, I mean, I guess you kind of are lifting into, but anyway, literal is probably makes more sense. So an add is an expert int, and then not is an expert bool to expert bool, and if expert okay. And then apparently there's more things that you can do. Okay. So this where, by the way, is where. Funny, but that's GADT syntax. So you can't write this without this extension. A good example is data. What do you mean by that? Okay, so this is like a syntax tree for a language, right? Uh-huh. Oh, I'll check to make sure it's not me. Nope, it's not me. I'm doing okay. All right. Okay, so it says that the ability to specify the return type is sort of the interesting part. You might be pleased that expr is correct by construction. We are incapable of building a poorly typed expr. While that doesn't sound immediately remarkable, I think it does. To me, it does. We've reflected the typing rules of expr in the type system of Haskell. We're unable to build an AST which attempts to add an expr int to an expr bool. Right? That's a pretty cool thing. So let's there's some GHCI stuff going on here, so let's check that. Well, type lidint. Yeah, and you can see. So this is the oh, neat. So 0 is a natural, and then okay, so it's a recursive data type with definition. I've not seen. Maybe I've seen that before. Why do I feel like I've seen that before? I'm not sure. Anyway, so we can. Maybe this isn't particularly interesting, but int if. Sorry. So we can see that in the type system. So because GADTs allow us to specify a data constructor's type, we can use them to constrain a type variable in certain circumstances. Such a thing is not possible otherwise. So what they're saying basically is you can start writing this function and do really cool things that weren't possible before. Well, fine. Not that that's strictly necessary, but value expr add I'm guessing it's x plus y. Oh, but I need to, I see. Wow, that's cool. Right, so you can write this because you know that this is an int. Right? That's an int. So to get an int out, you just apply this function recursively. That's cool. So I guess this is not eval expr x. Nice. Eval expr if bool xy equals b, then nope. Eval expr y. This is very cool. I like this quite a bit. It's fun to look at. Now, to be fair, I don't really know when I would want to use this yet, but it does look cool. I mean, clearly this case is an obvious one of when you would need this. Okay, so and then you can use this by writing the following. Eval expr dot if lit bool false lit int 1 add lidint 5 okay. So this is saying basically give me false. So I'm gonna get lidint 5, lidint 13 added together, and then we're gonna evaluate that expression and get an 18. How interesting. But does this have to be a dot? Or can this be like, oops, that's not gonna work. Can this be a $sign? Yes. Okay. So I think, I suppose all of these can be $signs? Okay. I just want to make sure that you don't have to use the composition the dot composition operator. That's pretty crazy. It's very weird looking. Yeah, so okay. So we should make this very clear. Right? This A is now a polymorphic type. Right? It can be int or bool or whatever. That's what you've done, which is the neat thing about this. Okay, so hang on. This is GADT syntax is indeed provided by the extension, but it's not the syntax that is interesting. The extension is poorly named. A more appropriate name might be type equalities. In fact, GADTs are merely syntactic sugar over type equalities. We can also declare expert as a traditional Haskell data type as follows. Do you want to write this? I guess we can. You can write this as a data type, but it just looks a little ugly. And so the GADT is just syntactic sugar over this. So let me show this real quick. I might not write the whole thing. I'll just write some of it. Let's do it this way. Space there. I'm just gonna leave it at this, and I'll put this down here. Etc. Right? So you can write this, I guess, without the GADT. Or do I need the GADT, the GADT for the? Well, let's find out. Yeah, okay. So you don't even need perfect time to introduce catamorphisms. Is it? I've heard the term catamorphism, but I don't remember which one that is. I only know endomorphism because we were talking about it in the Discord chat. Okay, so anyway, this is just syntactic sugar so you can write this instead of this. That's all it is. But now I want to look up the term catamorphism. You know what? I did just see there was somebody posted on Twitter a recursion schemes cheat sheet from, I think it was from EdMet, and I think that's who it was. But you know, that's definitely something I should look into. So actually, let's add that to our let's add that real quick. So recursion schemes, because those sound really interesting actually. Recursion schemes. Okay, so we're gonna add that to there. But I have seen that term before. That's something, right? So the only thing that they point out is that when you look at Expert like this, it's a little more obvious what's happening behind the scenes. So you have this constraint syntax here instead of, you know, you're enforcing the constraint, but you don't see that happening. This is just a little easier to read this way, I guess, but also harder to type. We will explore the technique of packing constraints. I've heard that term too. Can do. Conjugate hylomorph is okay. I don't remember what they're called, but one of them is the one where you create like infinite. Use fold to create like an infinite data structure, right? That's one of them. I don't know which one's which. Hylomorphism. Add potentially, well, we'll just write add interesting paper about hylomorphisms to recursion scheme. Okay. Thank you for that, World Center. That's useful. All right. So what's the next thing we're going to do? The next thing we're going to do is talk about heterogeneous lists. And to do that, we'll probably just create a new source file, hlist. And I guess we're going to be using GADTs, scope type variables, type applications, type families, and all kinds of stuff to make this work. So let's get to it. And I think we actually have some implementing to do, which should be fun. Language constraint kinds. 1, 2, 3, 4, 5, 6, 7. Data kinds. GADT. Scoped type variables. Type application. So one thing that's nice about Haskell IDE engine is that very densely written. So because this is your first stream, you don't know this about me, but I love dense theory. So I did theory in grad school. So I think I'm going to attach to this kind of stuff and really, really enjoy it. So, oh yeah, that's true. The formatter will force them on single lines after I run it. Well, I think it will anyway. We can test that. Type families, type operators. and then undecidable instances. So let's see what happens if I, yeah. So the formatter is going to put them on single lines anyway. So it's probably fine. So module h list where, and now we can start working. Data kind constraint type. Okay. So basically, what is this thing? This is, what does the H stand for here? Oh, heterogeneous, duh. So we're creating, yeah, I was just thinking about that as well. So H list is going to be heterogeneous list. So we are going to create a list that can have any data type in it. So it's like we're making a list in Python because you can put whatever you want in it. Yeah, we're going back to Python. No, I'm just kidding. I'm sure that there's very good reasons to do this that I just don't know yet. So I'm being cheeky and stupid. Anyway, so we can implement this like so. TS type where h nil h list some type an h list Oh, good point. That's actually a really good point. Dynamic at compile time only. That's a very good point. Thank you for saying that, because that's important. Well, it compiles, so I think I got it right. All right, so now I want to think about this a little bit. So this operator, I believe, comes from the fact that we've included this data kinds. Yeah, we'll get there in a second. So, well, actually, let's start here because that's where it's coming. So I'm pretty sure that this empty list comes from the data kinds extension. So this is a kind, I don't know what, I'm going to use the wrong terminology here, but I'm trying my best. The kind of empty list. It's a promoted data constructor. That's a better way to say it. It's a promoted data constructor that comes from data kinds. I'm pretty sure. And the same thing is true for this cons operator. So this is the promoted data constructor for cons. Yes, yeah. We're promoting values into the type system, and that's because of this. I think that's in my... We talk about that in chapter 2, maybe? So it would be the second YouTube video, which is, by the way, there. So we're going to put all of this on YouTube as a, like, just a playlist. That's the idea anyway. Okay, so that's what that is. So promoted data constructor for cons, and that just comes from using list here, I believe. Or does it always? It might be coming from this, actually. I'm trying. I don't remember exactly, but it's in there. But we can go look at it actually. Let's just look at it because I data kind type. Yeah, the kind of types with values. For example, int is type. That's why you can write this, and then I think because you're writing list of type, you get these promoted data constructors. I think that's how this is working. Somebody can correct me if I'm wrong. Please do, in fact. Oh, he might mention this. So h-nil represents an empty h list. We can see this by the fact that it takes nothing and gives back ts is equivalent to that promoted data type, an empty list of types. So think of that as an empty list of types, or the cons operator of types. So you can write, for example, using this, h length, h list es int. Yeah, right? Isn't that weird? Yeah, I think that's that thing there. So we should go thank whoever wrote that. You could also have a kind list of bool. You have a type level list of promoted bool values. Oh, right. It doesn't have to be type, but because we want this to be polymorphic in the type, that we have it this way. Otherwise, we could write whatever type we needed, right? Could we specialize hlist for bools? Like, could we? I'm trying to think of. I don't know how you would write it. I'm wondering. This is what I want to write, but I don't think that this is going to be correct. But yeah, this is the question. Can one write something like this? Maybe somebody knows the answer to that. Let me keep going though. Okay, so yeah, we don't need to know what this thing is, right? I'm saying, so kind of what you were saying. So like, what if we use, so we have this generic h list now. What if I wanted to specialize h list to a list of bool? Maybe. Oh, well, yeah. Okay, so you could just write this. I don't have to. I suppose it doesn't need to be data either. It can just be, oh yeah, type. Yep. Because it's just an alias basically. Yeah. Okay. That's what I was asking about. But I was trying to overcomplicate, which is something I do. Need a tick. A tick where? Really? Do I? It seems not to complain either way, so... I see what you're saying. So if we looked at the type behind the scenes, it wouldn't be correct. I see what you're saying. I'm guessing it's something like this. Yeah. TS. I'm gonna try and write this without looking. I'm already doing it wrong. So it doesn't matter what this is. This can't be right. Because I'm writing the wrong thing. I'm comparing it to the wrong thing anyway. We need that. He's showing head, and I'm looking at it like, wait a second, that can't be right, but... I guess it's gotta be like this. This is really TS. I have no idea what I just pressed. Well, maybe you can't write tail. Yeah, the type is wrong. You need to write. I have no idea how you write it though. I don't think you can. It would. Yeah. Okay. Let me show head first, so that we see what we're trying to do. I was writing the wrong function. That's basically what was going on. So I think this one will work because the types actually work. Hang on. H head is H. Okay, so this works because these T's are the same and the type of TS doesn't matter. However, I don't see how you write tail in this case because you're never going to be able to get the right type for your tail. Okay, I gotta read this. Oh, no. Breador, that's not right because I'm returning an H list. Oh, well, tail technically is returning an H list. You're right. So actually, it's just this. Oh, yeah, but that's not going to work either. There we go. Okay. Yeah. So, I was not writing the right function. I was thinking of last, I guess. Is it last? How would we write last? Could we write last? Is it even possible? Because you don't know what the final return type is, right? That's for tail, right? Okay, that's kind of what I thought. Yes, but I don't know how to get the type right because you have to recursively call last, right? So what you're trying to get is like the whatever the type of the I don't know. I don't know that this is worth it because I don't know what I'm doing yet. Maybe we should skip this and write the ones that we know how to do, and then maybe we come back for it. Yeah, that's not going to work, but we can try it anyway. So we need to return. Okay, what if we don't write this and we just write the function? I guess, although we probably can't do that. So you're gonna have h last of whatever. Sorry, t h nil is t. H last. I mean, you know, this is approximately what it is. Oh, that's funny. Okay, so world sender is suggesting we try that, so I'll try that. So data. Yeah, it's not T though, right? If you put T in here, it's still gonna fail because this one is correct, but this won't ever work. But we can try. Let's try this anything. Maybe someone else has another suggestion to try, but I think that this would work. I suppose. Or I'll a any a, and then you just write any. A type level function to extract the last element. Right. How do I write the type level function though? Does this work? Those are usually implemented with type families. Okay, so we can do. Okay, I'm willing to try this. I don't know what I'm doing, but I'm willing to try it. Could someone give me? Let's see if we talk about type families first. We do. Okay, so let's see if we can do this. H reverse. I suppose you can do H reverse. I think you can do H reverse, so we could actually do that. Well, I don't know, but we can try it this way. We're gonna talk about this anyway, so let's do it. So we need a type family called what? Last? I've never done this, so I'm doing my best. Oh yeah, I deleted it, right? Isn't this right? Data any oral a any a. Anyway, I don't think this is quite right. So what we need is, I guess, this type family idea, which I don't know if I can do it, but I'll try. I see what you're saying. Let me comment this out for a second. And then why does this fail? Do I actually need the T here? Okay, well, I mean, it's interesting nonetheless to write it this way. So we think that it's this? Oh, well. Do you have any explanation as to why this works, but the TS does not? Is it because I need to, I don't know what the right term is here, but I can't look at this lazily. I need to actually pattern match on it, otherwise I don't get this T. Yes. Okay, so I think I'm thinking about that right. So I need to explicitly pattern match on this T. Otherwise we don't know. How strange. This is pretty wild. Mm-hmm. That's pretty wild stuff. Let's see if we can write it with type families, because now I'm thinking about this. I'm kind of curious to see if I can figure it out. I suppose I'll call it H last, because although I guess it doesn't have to be H, it would just be last. TS type. I just want to point out this is the first time I've written one of these, so please don't make fun of me. Last. I guess this needs to be unit. Maybe this is not, maybe this is really, oh, well, first of all, missing a where. Okay. I really don't. This needs to be a T. But it needs to be a constraint. Do I need two type families? One for like one to wrap this T in? Oh. Okay. I'm looking, yeah. Again, I don't know what I'm doing. I'm just looking at the page in this book, but I see what you're saying now. This makes sense. So I need a type. But it can't be an empty list here. It would probably need to fail, so let's just get rid of that and see if this works. Okay. So this works. I don't know how to deal with an empty list. But let's not worry about that maybe for now. And then we'll comment this out as sort of, and let's put this down. So let's do this and then put a note in here. So original, non-ideal implementation of HLast. And then, so here, we're going to write HLast, HList, TS, I'm looking confused because this feels wrong. This will be almost the same, so I can keep this. I'm guessing. I really don't know. Wait. Can I just put a T here with this implementation? Apparently not. This. Yeah, if TS is weird. So just for reference, I'm like mesmerized at the moment. So does that fix this? It just fixes the whole thing. Okay, so the real question is, can I just get rid of this? That's what I'm most curious about. Like, no, I can't. You still need it. Oh, Shift U. You still need it like this for it to type check. All right, so the only other question we have here is how do we deal with this situation? Does it just have to be this? Because technically we also have we can write it that way. Hang on. What is it? Why is it green? Now implement map and filter. We don't. Do we not need to? No, we don't, right? Because it's in the type system that it's this. You're absolutely right. I'm explicitly asking for a H list with one element. Yeah. Awesome. So I don't have to deal with that type because this is my H list here is actually a non-empty list. Now up here I can have an empty one. Is this the correct representation of that? That's the only other question I have. Should I leave that there for it to be correct? I guess I should say correct in theory, because in practice I don't know what's gonna happen. Or would I explicitly write something like I don't know. I mean, this is really going to be a failure, but let's just write unit? Is that the type of it? I don't need to have it there. Okay. But if I had a situation like this, you know, I could do something, right? I'm just going to comment this out. But I'm just for my own sanity, I could explicitly write this to write H last with this type signature. Although I suppose I can't have the same name, can I? Okay. Perhaps shouldn't the last type in an empty list? Oh, good point. It's not defined. It's not defined for that case. So this would be like, I don't know. I don't know where would I error? This is the part I'm having a hard time with. Because I can't write two of these functions, right? I'm just gonna... I can... How would I... Okay, so let me see if I can say this better. I mean, it doesn't make sense to have this function. It only makes sense to have this function and this type family. Right? Because last is not even defined for the other case. It would error out. So why even put it into the type system? Is that the logic here? We shouldn't even write it because it doesn't exist in the type system? Like, we don't even want you to write it at compile time. Correct? Yeah. Okay. So it's going to say something like, it's going to say something like, that doesn't exist at compile time because you shouldn't even do it in the first place. I think that's the way to, or the way I should think about it. Okay. But, okay, so, Benjamin, I guess the part that I'm having trouble with is how do I even write that function? Because don't I, like, I can't rename HLast, right? You would have to literally call a different function for that to work. Or do I write some sort of wrapper that can deal with both cases? Sorry, I'm having a hard time thinking about this. Or, well, no, I can't do that either. I don't know what I'm supposed to do. Or I don't know how I add that type error. That's the part that I don't know. If somebody has a good idea for how I would do that, I would appreciate it. Let me go back to either World Center or Benjamin wrote an interesting syntax, which I... Oh, yeah, okay, I understand that syntax. Never mind. I thought I didn't understand that syntax, but it's basically ts at underscore underscore and then ts. I thought I didn't understand that signature when you put it up here, but I actually do get it. Okay, cool. That's neat. So now we have a heterogeneous non-empty list, or we can run HLast on a heterogeneous non-empty list. Okay, I add it in the type family. I want to add this because I'm legitimately having a hard time understanding where I was supposed to add that. So for future me, this is going to be really useful. So import GHC typelets type error, and it's text. Okay. So import, what is it? Data.text, I believe. Text. Whoa. So, oh, this is a different text. Is it in type error? Thank you for saying that. Type, I see. So I need text type error, or are those actually, yeah, like this. So type error text empty lists don't have a last type. Okay, thank you for that. I've not used typelets at all. Okay, but now we have a error. Parse error. Oh. You just said this, but I wasn't reading carefully enough. Or I didn't internalize it. Good night, Bredor. Thanks for coming. Appreciate it. Text. Error message. Jeez. I swear I can read. I'm so confused. It did say write it like this. I don't know what this means. I just realized I've never seen this syntax before. But I can't write this. I should just go look at the GHC or the thing real quick. Is there like package information about this? I've just never seen this before, that's all. I'm fine with writing it and ignoring. Thank you. Okay. So this okay, so I'm importing a single data constructor from the error message type constructor. Or, well, some type. All right. It's, yeah. Okay. I think this makes sense. Yeah. It kind of makes sense. I've just never done it before, that's all. Okay. And then that just works. Look at this. Man, this is really neat. This is really neat. Okay. Now we need to do some other stuff. So hang on with me. Hang on for a second. This is really neat. I'm having a lot of fun with this. It's kind of strange, but I can see how it's useful. We can also write, apparently we can write pretty interesting functions like this, although I suppose we already know that. What's this underscore? I've never seen this underscore syntax before. My goodness. All right, so oh, right. Can I though? Maybe I can. Because the just error out the pattern match for H now. And by error out, you literally mean this, right? Man, how cool is this? So really, the only reason this wasn't working before was because we didn't have this last type, right? Well, and we were explicitly pattern matching for a list with at least one element. But now we can write this because we have this. Okay. No, this. I think that makes sense. I'm gonna have to think about this a little bit more, or maybe we just need more examples. But this is really neat. So Okay, so this, I've never seen this before. So what's this about? Let's see if there's any mention of this. Okay, so I mean, I understand the fact that this is a list of 3 elements because we're not using some sort of TS. Oh, that's what I mean, I've seen typed holes before, but wouldn't that cause, like, why does that not matter? I mean, what if I just put A and B in here or something? Does it matter? Yeah, like it looks like a typed hole, like that's the same syntax, right? But it doesn't seem to be a typed hole in this case, because if it was a typed hole, wouldn't GHC complain about it? Like it's fundamentally different than this, right? Maybe. No. Undecidable instances, but not partial. I don't know what this one does specifically. So I'm not sure. There's, as far as I understand, as far as I noticed, there was no mention of what that was. Let me see if I, let me just double check. I don't see anything about the name for that, if, because it doesn't, it's a little strange, but it seems like this is completely equivalent. Well, this is actually a typed hole, right? I think. No, this gives you, oh yeah, found hole. Yeah, no, they're not, because this is actually a typed hole, but this apparently is not. Yeah, maybe. Like that's, like somehow this is equivalent to A and B. Yeah. I've never seen this before, that's all. So apparently a typed hole can only appear on the right side of an equals sign. Maybe that's the way to think about it. And these are just like, I don't know, just like any polymorphic type in this case. Well, literally any type, right? Any type. Let's see. I'm wondering if this is a straight up syntax error. Enable, yeah, it says enable partial type signatures. Hmm. Is this worth asking in the Discord, do you think? Maybe somebody knows the answer to this. But it did say when I got rid of that, turn on partial type signatures, and then it would work. But maybe this is like alpha equivalent to A, B, C, or D in this case. Anyway, this is kind of interesting. Weird for sure. Okay, so _1 is a valid identifier at the term level. I will believe you. Yeah, uh, World Sender, I can. Well, you'll see the titles of the. Or do you see the titles in Discord of what this is called? I'm pretty sure that this posts to Twitch. Yeah, it does. Variance type applications GADTs. So yeah, just keep an eye on the Discord, and I'll try and write when I do the kata and hylomorphism type stuff. But to be honest, it's going to be a while. I don't know when I will be able to do it. Um, if you remind me, I can try and like tell you about it, but it might take, I might forget. Just warning you. That's all. But thanks for stopping by. Okay. I think I got something wrong here. Um, instance eq. Yeah, this looks right. So I think I just need to include this flexible instances thing. Sure. What? Or Smith on Discord, or what's Smith? Oh, nice. Uh, Benjamin Franklin found it. Named wildcards underscore a are currently parsed as type variables. So yes, underscore one is just any old type variable. Um, flexible instances. Yeah, yeah. Was gonna get to that next. Alrighty. So something's going on here. Eq t, eq h list ts, eq h list t ts where contexts. Okay, so maybe I missed where he mentioned to turn on those things, but that's okay. We figured it out. Now this is super cool because we're basically recursively calling equal equal on this instance, and basically just finding all the heads. So as soon as these don't match, I guess it fails, and then you're done. Or it will only match until you get H nil H nil. Do these things have to always be the same length? Are we enforcing that? I think we are. Like, I think we're enforcing at the type level that we can't compare lists of different lengths. I suppose I can just try it, right? Um, So yeah, you can't even try and compare things of different lengths. So this has to be as such, and then it will compile, and f will turn out to be false in this case. It's pretty neat. They have the same type, they have the same length. Yeah, that's very true. This is really neat. I suppose I don't need to... Okay, cool. So now we have to write... What time is it? 10:15. Do I want to do this? Do I want to finish this? I kind of do, but kind of also don't. Okay, I think I want to save these for next time because technically it's past my time to stream. So I think I'm going to stop for the night. But next time what we're going to do is we are going to implement ORD for the H list and implement show for the H list. And then there's one more exercise which says rewrite the ORD and show instances in terms of all. So we're going to write a type family all and then rewrite our ORD and show instances using all. But that will be it for constraints and GADTs, and then we'll move on to rank and types, which look wild. So hopefully I can spend some time on rank and types by Thursday, and if I can't, then we'll go back and we'll write tests for the variance chapter, something like that. So anyway, we'll see what happens by Thursday, because I really don't know what I'm going to have time for. So, you know, it's really how it goes. So for those, I think everyone's kind of been hanging out with us, but that's the book we're working on. And, you know, you can go pick it up. It's a pretty cool book thus far. This is the ebook. If you want it as a physical book, you know, I always thought there was a link on this page, but I don't know where it is for the physical book. Anyway, the physical book you can get on, I think it's lulu.com. Yes. Thinking with types. And that's the physical book I bought. That's where I bought it, from here.